ladies and gentlemen.
So let's talk percentages. So percentages are essentially a ratio where the quantity is being compared to 100. You can get that for the cent part of percent, which stands for the 100, the per meaning of, so of 100. So 25% can be written as 25 100ths, which you could also convert to a decimal as 0.25. So anything within the hundredths place would represent the whole number of a percentage, while anything after the hundredths place, starting with the thousandths place, would start to represent the decimals of the percentage. So, sounds a little complicated. I promise you it's not. So, 27 of 36 students passed the test. What percentage of the class did not pass the test? Well, first and foremost, we need to figure out what the number of students who did not pass the test was. So we're going to do the total minus the number that passed, which was that 27. 36 minus 27 would give us 6 plus 3, which would give us 9. So 9 students did not pass. So what we're going to do now is we're going to set up a proportion where we have a ratio is equal to a ratio. We know that 9 students out of the 36 did not pass, and we want to figure out what number of 100 didn't pass. So we're comparing it to 100. So we need to solve this equation. So first thing we can do is we can reduce the ratio of 9/36. Both of those are divisible by 9. So that would give us 1/4 is equal to x over 100. And you can kind of solve that in two different ways. You can either make the 4, the denominator of the other ratio, equal 100 by manipulating that fraction, or you can solve it traditionally and get the x alone by isolating. Either one is fine. And I'll actually show you both so you get an idea of what I'm talking about. So let's do this one solving. So let's solve like normal. So if I take the 1/4 is equal to x 100ths, I would solve this by multiplying both sides by 100. I missed. Oh well. 100 times 1/4 would be 25. So x is equal to 25. The other way would be to get common denominators. So if I have 1/4 is equal to x over 100, I know that I can turn a 4 into a 100 by multiplying by 25. So I'm going to multiply top and bottom, numerator and denominator, both by 25. And that would give me 25 100ths is equal to x 100ths. So it stands to reason that x is equal to 25. So both of those ways are fine, and whichever one makes more sense to you and resonates with your brain a little bit more, stick with that. I would say that solving, once we get to more complicated ones, would probably be preferred, but the common denominators is a very unique way of trying to combat the problem, which I definitely encourage. So the last question was a question on just straight percentage. Now we're going to be asked about percent increase and percent decrease. So traditionally, you might think a percent of 100, you can't go over 100%. Well, that only makes sense if we're not comparing something. So here we're comparing two numbers. In this case, we have 58,000 and 72,500. Because we're comparing those, there could be a possibility of having a percentage above 100. So do keep that in mind. Even though we're comparing to the number 100 doesn't mean that we can't go necessarily above it when we're doing some of these comparisons. So let's read the question. Last year, Taylor had an annual salary of $58,000. This year, his salary is $72,500. What is the percent increase of his salary? So whenever I do percent increase, percent decrease, I like to compare the new numbers to the old numbers. So new over old. It just helps me keep my mind in the right spot and make sure I don't mix up where any of my numbers go. In this case, new would be 72,500. Old would be 58,000. And this would be equal to some percentage over 100. It's going to be over 100% because we grew, which makes sense. Can we help ourselves out here? Well, I do see that we have 2 zeros in both the numerator and denominator, so we can go ahead and cancel those. And that leaves us with 725 over 580. From here, it might seem unclear of where to go, but I see that the units digit for both of these is 5 and 0, which means that both of these numbers are divisible by 5. So, how many 5s go into 700? That's a little weird to think about. How many 5s go into 100? That's easier. That's 20. So, we have 20 for 100, so 700 would be 7 times that, which would be 140. How many times does 5 go into 25? That would be, 5. So the numerator will reduce to 145. The denominator, how many times does 5 go into 500? Well, 20 for 100 times 5, which would be 100. How many times does 5 go into 80? Well, that would be 16. Now, this still looks ugly. It still looks like we can't do much with it. But that's where we can rely on some old-fashioned long division. Oof, I know. Let's try it out, though. So, using long division, I can put the 145 in its own little box-ish, and 116 outside. How many times does 116 go into 145? Well, it goes in once. So we're going to take this and we're going to subtract 116 from it. That goes away. That gives us a 3. That gives us, not quite a 3, because we have to borrow. So that's going to turn into a 3 here. 15. That gives us a 9. That gives us a 29. And now we need to figure out how many times 116 goes into 29. Well, to do that, we're going to add a point and then add a 0. Drop that down. How many times does 116 go into 290? It goes in twice. So we're going to put a 2 here. 2 times 116, well, 2 times 100 is 200. 2 times 16 is 32. So now we can subtract. That's easy. The 100s are going to cancel. But we can't do this 2 minus 0, so we're going to borrow. 2 minus 10, or 10 minus 2 is 8. 8 minus 3 is 5. So now we have 58. Again, we're going to need to add another 0 here. So how many times does 116 go into 580? Well, it's going to go into 580. Let's try 5. 5 times 100 is 500. 5 times 16 is very similar to timesing by 10 and dividing by 2. So 16 times 10 is 160, divided by 2 is 80. We actually get 580. Gives us a remainder of 0. So this whole thing reduces to 1.25. Surprisingly enough. To solve the final equation now, we'll just have to multiply both sides by 100. 1.25 times 100. X is equal to 125. So his salary grew by 125%. And that question wasn't necessarily difficult. If you had access to a calculator, done really easily, right? But you're not always going to have access to one, so it's always good to have these skills handy and fresh. So our last question here deals with growth. So a type of sapling grows in height by 10% each month. What percentage will the height of the plant increase in 2 months? So we don't know how tall the plant is initially, but we don't really care, right? We have it's X tall. If it's growing by 10% each month, it is going to be 110% of what it was for the first month. Then we're going to multiply this again by 110%. Why? Because it's growing by 10%. If I multiplied it by 0.10, it'd be shrinking. So it's 1 plus the percentage for growth. Now, in order to clean this up, I need to multiply 1.10 by 1.10. So 1.10 times 1.10 might seem a little trivial, but we'll try it out. So 0.10 of 1.10 would be 0.11, and then 1 times 1.10 would be 1.10. If we add these together, we get 1.21. So a little weird, but we get 1.21x, which means that it grew. By what percentage will the height increase? It will grow, or increase. Let's do increase instead. It will increase by 21%. Keep in mind that we needed the one there for the growth. The moment we say it's increasing, we get rid of that. So we're focused on this here, and we want to make it a percentage, so we need to multiply it by 100 to turn it into a percentage, and that's where we got the 21 from. So interesting, but not difficult. It's a lot of remembering of more simpler things. If you have any questions, please let me know. Otherwise, I look forward to seeing you in the next video.